Our next problem is a very interesting problem. We are given with a long quadratic equation x minus b up into x minus c upon a minus b a minus c plus two other terms written in cyclic fashion, and we need to prove or we need to find the value of x satisfying this long quadratic equation. Now one of the method can be taking the LCM, writing the x square, the x and the constant terms, and then finding the value of x. But the more easier and a very interesting solution of this quadratic equation is as follows. We see there are similar type of terms in the numerator and denominator. Here there is x minus b, in denominator there is a minus b. Here it is x minus c, here it is a minus c. We are seeing then the numerator has been changed to denominator just by putting x equals a, and similarly in the two other terms also. So we put x equals a. We see on putting x equals a, this becomes a minus b into a minus c upon a minus b a minus c, which is equal to 1, plus this becomes 0 since it is having a factor x minus a, and this also becomes equal to 0 since it is also having a factor of x minus a, equals 1. We see 1 equals 1, hence this quadratic equation is satisfied for putting x equals a. Similarly, if we put x equals b, we get this factor equals 0, this factor equals 1, and the last factor also equals to 0. Hence the quadratic equation is again satisfied, and hence x equals b is also a solution of this quadratic equation. And similarly, putting x equals c, we see this factor becomes equal to 0, this factor also becomes equal to 0, and this factor becomes equal to 1, which again satisfies the given quadratic equation. Hence x equals c is also root of this quadratic equation. Now we are seeing that x equals a, x equals b and x equals c, that a, b and c are all three roots of the given quadratic equation, and we know that a quadratic equation can have at max of two roots, and we are getting three roots of this quadratic equation. Hence this is actually not a quadratic equation, it is an identity. So it is satisfied by infinite values of x. So the roots of this quadratic equation is x belonging to R, which is the final answer.